3.7, number 265. We have the function f of x equals 2x cubed minus 3 and x equals 1, I guess is the point we're concerned about. So part A says find df dx. Okay. Find the derivative of this function at x equals a. Okay. All right, no big deal. Nothing new here at all. So we'll take the derivative. So f prime, I'm just going to use the other notation, the tick notation. So f prime of x will be, using a power rule and a constant rule, we'll just have something like 6x squared. Okay, so f prime at 1 then is 6 times 1 squared equals 6. All right, so we have the first part. Part A is complete. Part B, find x equals f inverse y. Now they really didn't, it doesn't really matter if you use x equals f inverse y or y equals f inverse x. It all means the same basic thing, and that is find the inverse of the original function. So the usual thing you do is you replace the x's with y's. But in this case, since they said x equals f inverse y, I am not going to replace the x's and y's in this case. I'm just going to leave it how they are. Y equals 2x cubed minus 3. And I'm going to solve for x. And that's all they want, right? You're solving for x in terms of y. When you do that, you will have uncovered what f inverse is. Right? So I need to get x by itself. So I'll add 3 to both sides. I have y plus 3 equals 2x cubed. I'll divide by 2, and then we'll take the cube root of both sides. Cube roots never necessitate a plus or minus, so we end up with x equals cube root of y plus 3 over 2. Let me get that a little further. All right, so there's our, that's f inverse y, we got him. So that's part B complete. Now, we're supposed to use part B to find the derivative. Right? So part C, find the derivative of the inverse we just constructed. Sorry, the variable is y. At y equals f of a. Y equals f of a. Okay, so for us, our a value was 1, so we need f of 1 here. F of 1, if we just go back, we just do it by inspection here. You plug in 1, you're going to get negative 1 out of here. Okay? So I'll just rewrite that down here. We know f of 1 is 2, 1 cubed minus 3 is negative 1. All right, so we need to find the derivative when y equals negative 1. Right? So you need to take the derivative here. So df inverse dy, right? Looking back here at our inverse rule, we'll always view these roots as powers. We're going to change this to a 1/3 power, right? 1/3 power. That's how we imagine it. So the 1/3 will come down. The inner function y plus 3 on 2 stays the same. Lower the power by 1 to negative 2/3. Now we have to multiply by the derivative of the inner function y plus 3 on 2 using the chain rule. And when we do that, we'll just get 1/2. All right. So clean this up just a little bit. We should have 1/6 y plus 3 on 2 to the negative 2/3. And now we will use this negative up and take the reciprocal of what we have in here. So we'll end up with 1/6 2 on y plus 3 to the 2/3. We should need to evaluate this at -1 for y now. Right? So df inverse dy at y equals -1 will be 1/6, 2 over -1 plus 3, all raised to the 2/3 power. So 2 over 2 is 1, 1 to the 2/3 is 1, so this is 1/6. And we have our answer.